caching section. Okay, so we are entering into a new section, caching section. Under this section, we will be looking at the CloudFront and Elastic Cache, and some of the extreme rates. We would be handling such of those in solution architecture. So first of all, we will be starting here with the CloudFront, and this lecture is going to be long. I think more than 30 minutes for sure. So let's begin with the CloudFront. So the CloudFront occupies a big part of the exam. So I want to make sure we cover CloudFront properly. It is a very complex topic, and there's a lot more information in this course than in the other sources that you can find at the documentation even. So just the basics, CloudFront is a CDN, content delivery network. Okay, and it helps you improve the read performance by caching content at the edge. And what is the edge? Well, here about 300 plus points. We have presence globally edge locations, and AWS keeps an edge locations over time. So this number may already be outdated, 30. Okay, what CloudFront gives you is DDos protection, integration with Shield for DDos protection as well. And web application firewall, WAF. If you wanted to filter some request at the edge, you can expose HTTPS endpoints, and you can also optionally talk to internal HTTPS backends. And we'll see in this details in the the details in its own lecture, because it's very important to understand how this exactly works. Okay, so if we look at the CloudFront at a high level, we have, for example, in S3 bucket in Australia and a user in America. And so instead of directly talking to the S3 bucket in Australia, my user is going to talk to an edge location in America, and the edge location is going to retrieve the content from the bucket in Australia. The idea from this is that if another user in America requests the exact same content, they don't have to go all the way through the Australia. They can just go through the same edge location in America and get the same contents. So the idea is that another user, for example, in Asia will go to the another edge location, maybe in Japan, and the Japanese edge locations will get the content from S3 cache at the edge, and so on. So this is the basic of how CloudFront works. So now let's talk about the different origins for the CloudFront. The first one, as you know, an S3 bucket. So this is very helpful when you want to distribute files, and then if you want to securely access to the S3 buckets, so you must choose the CloudFront Origin Access Identity, or OAI, Origin Access Identity. So CloudFront basically can also be used as an ingress, and this allows you to upload files. Upload files to Amazon S3 through CloudFront Origin. Now you can also have an S3 bucket configured as a website. So first you need to enable the static website hosting on the bucket, S3 bucket, and then you would actually use the CloudFront front it with the CloudFront, and you can also CloudFront with a media store container and media package points. So this is used to deliver video on demand VOD, or live streaming videos using the AWS media services. So some things remember at the exam, if you see media store container or media package endpoint, you can also use CloudFront with any custom origin that is compliance with the HTTP protocol. So it could be an EC2 instance, it could be Elastic Load Balancer, for example, your classic load balancer or your application load balancer. It could be an API gateway. For example, that gives you more control than using the API gateway edge feature. So you just do CloudFront plus API gateway, or it could be any HTTP backend you want, and even your on-premise instances also. Okay, so what does the CloudFront look like when S3 is going to be the origin of your CloudFront distribution? So within the CloudFront, within the cloud, and it's big, you have the S3 bucket. The origin is in one region, and so CloudFront is going to be defined using an origin access identity, OAI, It's like an IAM role for CloudFront, and it's going to be allowed to talk to S3 buckets through an S3 bucket policy. The idea with OAI, origin access, OAI is that as soon as this is in place, no one can access the S3 bucket, but CloudFront can. Okay, and so we have effectively secured their S3 bucket to guarantee that only way to distribute content out of it is through the CloudFront. So then we have so we have a lot of edge locations around the globe, maybe in Los Angeles, Sao Paulo, in Brazil, in Mumbai in India, and Melbourne in Australia. And so our users all around the globe are going to talk to our edge locations, maybe these users in Los Angeles and so if the Los Angeles edge location does not have the content that is requested, it's going to be requested over the private AWS network. It's going to be quick and it's going to be cached at the edge. The idea is that the more user request the same file, the less round trips to the origin S3 bucket, which maybe in Europe, for example, will be necessary. This is the true for the Sao Paulo. So there's another edge cache in Sao Paulo, and same for the Mumbai and same for the Melbourne. So this is the idea. Your S3 bucket will get received. We receive request from all these edge locations securely, thanks to the origin access identity, and the aggregation themselves will serve the content to the public, usually at the lower latency and with increased cache hits. So we'll be talking about how to increase the cache hits, by the way, in another lecture. So that's for the S3. This is very simple. It's something you have probably have seen. But what about if you want to have EC2 or an application load balancer and ALB as an origin of the CloudFront? So so this is here. This is rather new. So we have our EC2 instance and it must be public. And has a security group around it, and it exposes an HTTP server, and we want to have CloudFront in front of the HTTP server. So we'll have a bunch of edge locations around the world, and the edge location need to be able to reach our EC2 instance to get the content it needs. So therefore, for the security group must allow the public IP of all the edge locations into it. And thankfully there is a link on the bottom right corner have been included this slide, which shows you all the public IPs of all the edge locations, and so you have to enter all these public IPs into your security group, and it will allow your edge locations to reach your instances. So this is the optimal way to have security, and as you can see here, the traffic between edge locations and your EC2 instance is going over the public internet. It does not go over the private internet. This is only when you have S3 as an origin. When you have a custom HTTP backend, such as two instances, EC2 instances, like it must be going over the public internet. So that's very simple. Next, we have more complex architecture with an application load balancer and a security group with a EC2 instance in it, and those kind of group maybe and so we have still the edge location that have public IPs, and so now the network security looks a little bit different. So your application load balancer must be public, otherwise the edge locations will never be able to reach your application load balancer. So in terms of security group, this is just like above the security group of the ALB. ALB must allow the public IPs of the edge location to get in, but when it gets your security group of your EC2 instances in the backend, these EC2 instances can be in private subnet, just like we have seen from the before. And the best practice in this case is to allow the security group of the load balancer into our EC2 instances. So this is very important for you to see it once to really understand how your edge locations are going to request to architecture, because it goes into network security and solution architecture everywhere. So okay, so in case, we have CloudFront and S3 cross replication. What is the difference? S3 cross replication, what is the difference? So what are the similarities? So CloudFront is going to go with a global edge network. So we are talking about over 200 points of presence, 200 edge locations. The files are going to be cached for a time to live TTL. It could be a day all around edge locations. So this is great when you have static content, and that must be made available everywhere with low latency, and you are willing to wait for the content to be outdated maybe for a day. Maybe even here with the CloudFront you have also the option to invalidate the cache. You will specify the file and that you will invalidate those cache. So S3 cross region replication is a little bit different. You must set it up for each region you want replication to happen in, and the files will be updated in near real time. So if you update a file in US-Southeast-1 region and it gets replicated to AP-Southeast-2 region, within a second or so, the file will be replicated, okay? So this is near real time. It's read only. So you can't have active replication. Okay, it's one bucket that gets replicated into other regions. And so it's great if you have dynamic content that needs to be available at low latency in few regions. Okay, the idea with S3 cross region replication is that you want to have the same content in different regions at a low latency. So as such they are very different. And by the way, this is just for S3 CloudFront. CloudFront obviously has not just S3 as an origin, and as we can see also has S3 has many HTTP backends such as your ALB and your EC2 instances, for example, or any on-premise servers that can be exposed through the CDN. Next, we will talk about the CloudFront Geo Restrictions. So it's feature to control who can access your distribution, and you have two ways of looking at it. Either you set up allow list, and this is to set up a list of approved countries that can access the content, or you can set up a blacklist, as this is to prevent users from the selected countries to select countries to access your CloudFront distribution. So the way it works is that a country is going to be determined by CloudFront by using a third-party geo IP database by matching the IP to a specific country. Now the use case for using geo restriction is, for example, to show that you are enforcing copyright laws and saying that some content can only be accessed by some countries. So that's here for the geo restriction. Now let's talk about the signed URLs and how they work. CloudFront signed URL, we'll go through this diagram. So signed URLs are a way to give a special URL to get access to CloudFront and contents. So CloudFront and this URL will expire. So how does that work? So well, our client wants to access, for example, our CloudFront distribution, which is connected to Amazon S3 in this example. As you will be able to see that now, Amazon S3 is just having an OAI. So how do we generate these signed URLs? Well, we need to create a special application server, and the application server has a responsibility to create these signed URLs, and this application server is trusted by CloudFront to create them. So the client is going to authenticate and get authorization to indeed request a signed URL from the application server. So there is a bit of the custom code here. Then the application server is going to use the AWS SDK to generate a signed URL for our platform distribution, and then return that URL to our clients. And now our client has a URL, has a specific expiration, and the client can access our CloudFront distribution using this signed URL, just as simple as that. So the question you may be asking yourself is, what is the difference between CloudFront signed URL and S3 pre-signed URL? So the first of all, CloudFront signed URL, they give you access to a path, no matter what the origin is. So S3 pre-signed URL is only for S3, as you will be able to see. This is the S3 bucket here, has been hidden by my view. But CloudFront signed URL could be for anything as an origin. In the previous example, I have S3, but it could well be an HTTP server running on EC2, your application load balancer, or even on-premise. So you have an account wide key pair that only the roots can manage it. and only that can create signed URLs. And you can filter by IP path. You can have a date and an expiration to your signed URL or your signed cookie. You have a date and you can also leverage the caching features out of the CloudFront. That means that if two people request the same signed URL, CloudFront doesn't go back and fetch the file from S3. It already knows it's cached, so it's perfect. So as an example here, we have as an origin an EC2 instance, and the client will use a signed URL to access some premium content onto our EC2 instance. And that looks very simple. The idea here is that the CloudFront is in between. CloudFront is in between. It gives us a level of security also. It gives us a content distribution facility, and this is great. S3 pre-signed URLs through DAO are different, very different. Their issue request as the person who pre-signed the URL, and if you are using, for example, an IAM role and you create from the IAM role a pre-signed URL, then whoever has that pre-signed URL will inherit the same rights as your IAM role. It has a limited lifetime, your pre-signed URL, and really the goal of pre-signed URL is either to download the files from S3 directly or upload the files to S3 as well. So and this would be temporarily, okay? Now it's gonna get a little bit trickier when it comes to custom origins, because there is no built-in way to do it, okay? So the idea is that, for example, an HTTP custom origin, maybe an web server, and we only want them to be accessible. We only want them to be accessible from CloudFront. So we have two ways of doing it, and one is going to be an application logic. So let's take the example of a user application. A user accessing our CloudFront is location and is going to give a few headers. Now the CloudFront is going to be set up so that what we get is that we are going to have a custom HTTP header added to the request, that it will be sent into your application load balancer and or your custom origin. So the idea is now is that there's an X custom header that is customly added with some random content in it, and this gets passed to the origin. Now the origin can be configured either at the ALB level or maybe your application level to only for request that contains that specific custom HTTP header. So otherwise to refuse the request. So in the ALB you can set up a filter and saying, hey, if that request has this header, then please forward it to your downstream instances, EC2 instances. This is the EC2 instance. So it's just refuse the request. And the idea is that if a user tries to do a request directly against your ALB, then your ALB will find the custom header it expects expects from CloudFront, and therefore will deny this request. So this will only works with if the custom header name and the values are kept secrets, but this should be fine, okay? Now you can also have a second level of security into this setup, as we saw before, in which we can restrict the origin to only have a networking access. So for seeing that part, I would be just hiding my view for a while. You can also restrict access to CloudFront public IPs addresses only, and there is a link below that to actually see some more of the information for that. So here, as we saw before, in which we can restrict the origin to only have a networking access from the CloudFront locations, and the CloudFront public IP addresses are available at the URL of the bottom right corner. So this gives you an application level security as well as network level security to access your custom origin. So this gives you an application level security as well as network level security to access your custom origins. Okay, now we would do some more CloudFront related discussions in the next slides. So this time around CloudFront caching, okay? So you will get questions on it, and it's very important you understand exactly how it works. It's very tricky, to be honest. So you can cache based on multiple things in CloudFront. The first thing is a header. The second one is a session cookie. The third is a string. Third is a the query string parameters. The idea is that if two of these values are similar, or two requests have the same values for the headers or cookies or query string parameters, and you set it up this way, then the cache response will be returned. Now each cache lives inside each CloudFront edge location, so you have multiple caches all around the world. So here is the anatomy of the request that the cloud makes a request. It may include headers, it may include session cookies and query string parameters. CloudFront is going to be set up so that it can check or update the cache based on the headers, the cookies, and also look for the TTL and see if the files are updated in the cache. And if the file is not in the cache, or it doesn't match any of the SEP configuration for headers, cookies, or query string parameters, then it's going to forward the request to the origin to get the value and store the value back in the cache, cache in case similar request comes in later. So the idea here is that we want to maximize the cache hit rate to minimize the request on the origin. Okay, a very efficient caching strategy. That's just that it is. Okay, now we'll see exactly how we can optimize this strategy based on what CloudFront can cache on. Okay, so finally the TTL, which is how long object will be cached in CloudFront, can be controlled from 0 seconds to 1 year. And to control it, we can set the cache control header or the expires header from an origin response to the CloudFront. So what the exam would test you on in terms of optimizing the cache is going to be on whitelisting headers. So here is what it looks like. So our client makes a request into CloudFront, which has its own cache, and it will forward the request back to the origin. Now the caching strategy in CloudFront can be set up to be cached on a specific count of headers. So before I give the answer, let's look at the common request from a client in the CloudFront may look like. So here's our request. And I'm saying yes, I want the image of a get using the protocol HTTP /1.1, and the host is the host header. So which website I'm trying to access, which is pix.mywebsite.com, which represents the CloudFront distribution. Here's my user agent. This represents the web browser someone is using. So it's Mozilla 5.4/5.0 on the Mac OS X. And here's the date of today. It's not today, it's certainly the 28th January 2020. Here's the authorization, which is what's my login information and can I access this file, and the key and the keep alive, and finally accept range bytes. And there's so many different other headers. Now the idea is that all these headers, if you look at all the possibility of all the clients around the world, like maybe someone is using Mozilla, but maybe you are using Google Chrome, maybe someone else using Safari, and maybe date is going to be changed obviously over time, but maybe the accept range bytes or the keep alive is going to be changing as well also. So there is a bunch of different values for all these headers, and if you tell CloudFront right away to cache based on these headers, but they can take so many different values, then CloudFront will forward every single request back to the origin. So origin, you maybe I will not be able to see that. So this is the origin. So the idea is that you need to whitelist, which means select which headers are important for you. That will not change very often, and that can have a cache value based on it. So we are going to whitelist some of our header, and we are going to say, okay, we'll keep the same get, we keep the host, and we keep the authorization header. So in this case, we have a lot less data and can be changing in this header whitelist because we have removed the user agent, we have removed the date and so on. So in CloudFront, we are going to say, okay, we need to cache based on the host value and the authorization value, and this is how it is. Very great. And here is we have better caching because less header values. So this is the kind of things to the exam will be testing you upon. Now here we have better caching because less header values. So this is kind of things the exam will be making some of the solution architecture related questions. Now there's another strategy to maximize cache hits, which is to separate the static and dynamic content. So in your distribution, so if you separate both, what happens? Well, you have the CloudFront layer and all the static requests will go to one distribution, which will get the static content out of the S3. The beautiful thing is that about the static content is that usually you don't need any header, you don't need any session caching rules. So anything that gets static doesn't change over time, could be cached at the edge. And so thanks to this route we are going to maximize the cache hits for all the static contents. And then we have the dynamic content, which is going to be relying maybe on an API which has the REST and HTTP server, and here we can cache based on the correct headers and cookies, just the way I showed you in the previous slide. And say, okay, you need to whitelist these headers, you need to make sure you take this into account and not take this into account. And so this gives you a more granular cache. So in this case, we have two caches because we have two CloudFront distributions, but we have maximized the chances of hits by separating the static and the dynamic distribution from CloudFront. So this is a very important strategy. Finally, let's talk about the CloudFront caching and API gateway caching. So we see from the API gateway, if you deploy it in the edge mode, the API gateway lives in one region, for example, EU West 1, US East 1, and it has a cache attached to it, and then all the content is going to be going to redistribute through edge locations around the world. So if your user accesses it, it will be routed really quickly to the API gateway. But this is just how it works normally. And next we have the option to choose an API gateway that is going to be regional. So going again, we have a cache at the API gateway level, and we decided to create ourselves a CloudFront edge distribution to have more control. So the idea here is that we are not using an edge API gateway, we are choosing a regional API gateway, and this way we have full control over how the CloudFront distribution works over our API gateway. So this is maybe something you want in case you want more control over your distribution, but this is really up to you, okay? And it depends on the solution architecture. But one really interesting side effect of this is, even though these two solutions are similar, is that now we have a third option. So in this option we have we have an API gateway that's going to be regional, and again the cache is at the API gateway level. But now using CloudFront Edge, the CloudFront distribution in the edge location, we have the option to have caching facility at the edge for your API. So it is possible now, thanks to separating the CloudFront distribution out of your API gateway distribution, to have caching enabled at the edge. And if you set it up correctly, okay. So again, it will depend on your strategy on how you configure CloudFront. But these are different kind of solution architectures. And so as you can see, the little tweaks to settings have big implications, because if we are using the edge at the CloudFront side, then we can optionally disable the cache in API gateway maybe, okay. So it's really up to you to see how you are designing your whole infrastructure. Right now, just want to open up all the possibilities through you, and obviously it's your role at the exam to really understand what the exam is asking you to make the right decision. Okay, so this is all about the CloudFront caching, and next we are going to talk about the so CloudFront has more capability than just a CDN. Okay, just a CDN, it has this allow you to run custom code at the edge to do some customization. Okay, so the idea is that you want to execute edge functions as close as possible to users to make sure that you are verifying some early logics, some early behaviors, or normalizing some cache keys. Okay, so an edge location is a code that you write and that you attach to a CloudFront distribution, and it will run very close to users in order to minimize the latency of whatever you are trying to do. It doesn't have any cache behavior, it's just here to change the request and response sent by the users and back to the users. Now CloudFront has two different logic for edge locations. It has the CloudFront functions and Lambda at edge. We'll see both of them in this lecture. So the use cases for customization at the edge is to manipulate HTTP requests and responses, is to implement request filtering before reaching our application, is to verify the user authentication and authorization, is to also maybe generate HTTP responses directly at the edge, or do A/B testing by separating users into two groups, or for example being bot mitigation at the edge. So the idea is that using edge functions, so either CloudFront functions and at the Lambda at edge, you do not have to manage any servers. Everything is deployed globally and it is serverless. Okay, so if we look at the traditional architecture of CloudFront, we have our clients to our edge locations, talking to our regional edge cache, talking to our origin. Now Lambda at edge functions are going to be deployed at the regional edge cache level. Okay, where the CloudFront functions are going to be deployed at the edge locations. CloudFront functions are deployed at the edge locations. So as you can see, two different levels for deployment of these functions, and that will impact your choice between the CloudFront functions and the Lambda at edge functions. So if we look at the CloudFront functions, they will interact with the viewer request and the viewer response. These are the request and response that happen between the clients and the CloudFront. It does not modify origin request and origin response. So these are lightweight functions returned in JavaScript, and they are meant to do high scale latency sensitive CDN customization. So it is sub-millisecond startup time. Like it's very quick to start, and it can handle. You will be able to see that now. That's the origin response, and the bottom one, the server that is being shown as the origin. So it can handle millions of requests per second. So we run at the edge location, and it's a process-based isolation. So you want to change the viewer request and responses, as I said. So what is a viewer request here? So well, it's after our CloudFront receives a request from a viewer, and your response is before CloudFront forwards a response to the viewer. So the idea is that it's a native feature of CloudFront. You manage the code directly from within CloudFront, and this allow you to do some quick time-sensitive transformations in CloudFront. Okay, the idea is that you cannot call external services from the CloudFront function. You just want to perform some transformation, some computation, or some normalization in a very quick fashion. Now, Lambda at edge is a different mindset. So these were first what CloudFront was offering as a feature. CloudFront functions are new. CloudFront functions are new, but Lambda at edge has been existing for a long time. And the idea was this is that you have Lambda functions that are written in either Node.js or Python, and you can scale through thousands of requests per second. So less scale than indistinct functions for sure, and they run on the nearest regional edge cache. So they are virtual machine based isolation. and they are used to change both CloudFront request and responses. So we can change the viewer request, the origin request, which is the request that the CloudFront sends to your origin. You can change the origin response, so the response that the CloudFront receives from the origin, as well as the viewer response. Okay, now when you want to deploy Lambda at is functions on CloudFront, you need to author your functions in one region, which is a USHT 1, and then CloudFront will replicate this function to all its regional edge caches. So now if we have a look at how these things can be used together, so we have edge locations and regional edge cache, and so the view request goes all the way like this. Then it goes through the origin. Let me see. And then the origin response goes all the way like this to the viewer response. Now your CloudFront functions are going to run on the edge locations at the viewer request and viewer response level, whereas your Lambda at edge functions are going to run at the origin request and origin response level. This is if you want to use both CloudFront functions and Lambda at edge functions together. Okay, so this is one option, and we can see a clear separation of both Lambda at edge and CloudFront functions. But if you want to just have Lambda at edge function, then in that case, what's going to happen in the Lambda at edge functions are going to operate on both of your request response and the origin request and response, but only at the original edge cache level. Okay, in this case we cannot use CloudFront function because we cannot use both Lambda at edge and CloudFront functions on the viewer request and the responses. So this is when you need capabilities of Lambda at edge that are not available with CloudFront functions. For example, if you need a longer execution time, network access, third-party API calls, these kind of things, then you will be using the regional edge caches and Lambda at edge functions. So if you want to compare the CloudFront functions and Lambda at edge on the table, so while the runtime support is different, so one is JavaScript, pure JavaScript code, the other one is Node.js and Python, where it gets executed is on edge locations for CloudFront functions, where it's original edge cache for Lambda, regional edge cache for the Lambda at edge. The CloudFront triggers are going to be viewer request and response functions, and all of them for the Lambda at edge. The isolation is a process based versus virtual machine based, and now the max execution time is what I think is the most important thing. You only get 1 millisecond to execute your CloudFront functions, 1 millisecond, and therefore they must be very quick and very simple, where the Lambda at edge you get 5 seconds of runtime, and very simple, where the 5 seconds of runtime for like viewers triggered for, and 30 seconds for runtime for origin triggers, 5 seconds for viewer triggers, and the 30 seconds for the origin triggers. The memory of your CloudFront function is a low 2 megabyte, whereas for the Lambda at edge you have more memory, 128 megabytes or 10 gigabyte for the origin triggers. The total package size is very small for CloudFront function, that's the 10 kilobyte, where the Lambda at edge it has more space, and like 1 MB for the viewer triggers and 50 MB for the origin triggers. So there's no network access, no fast system access for the CloudFront functions. File system access for the CloudFront functions, where you have some for the CloudFront Lambda at edge, and you do not have access to request body in CloudFront function, and you have access to it in the Lambda at edge. So CloudFront function is really about reading headers and so on And the pricing is that there's a free tier for the CloudFront function, and it's 1/6 of the price of the is Lambda at is. You are better off, and Lambda at is as no free tier available with the Lambda at is, and you get charged per request and duration. So when do you use CloudFront function versus Lambda at Edge function? Well, CloudFront functions are going to be used for cache key normalization. So you want to transform the request attributes such as the headers, cookies, and the query string, the URL to create an optimal cache key. You also want to manipulate your headers. So you want to change them. You want to insert, modify, or delete HTTP headers in a request or response, or you want to do your own rewrites or redirects or to request authentication and authorization directly at the edge. So in which you can create and validate user generated tokens. For example, ZWT to allow or deny request very close to your users, whereas Lambda at is going to be giving you a much longer execution time. Okay, so up to 5 seconds or to 30 seconds. Or you get adjustable CPU memory. You get to have code that can depend on third-party libraries. For example, you can use SDK to access other AWS services. You can use the network access to use external services for processing, and you have file system access. If you wanted to cache some stuff locally, or you can even access the body of the HTTP request to manipulate the body itself. So hopefully the use cases are clear and well defined for the CloudFront functions and the Lambda at is. Now if you want to do the authorization and authentication with CloudFront functions, the idea is that the edge locations, you would intercept the content and you would check the token and the distal ZWT token which lives in your headers, and then you can check whether or not it is correct. And then if it's correct, if it's not correct, then the client will get an error message directly without having your request to go all the way to your origin, whereas your Lambda at edge functions will operate on the regional cache level, edge cache level, original edge cache level, and it could be intercepted by Lambda function, which can do some custom logic and even issue third-party API calls to check whether or not the authorization or authentication is possible. So this one was Cognito or third-party OICD. So now another very common use case for Lambda at edge is to load content based on the user agents. So we have an extra bucket on Amazon Cloud with Amazon CloudFront with original edge cache, and we have users texting it from desktop. Okay. And other just texting from mobile. Now they both want to access a cat picture, so they do a request for the cat picture, and the resolution is high, so like 9020 by 1080.jpg, that's jpg file. And they request it from the CloudFront. So if the request goes well, the request is passed all the way to the S3 bucket to get that specific image. But the image, imagine that the same request is done from our mobile device, and this time the user is not Chrome. It is like the iPhone OS Safari. Now what we can do is, instead of sending this big image back to our mobile, which may be very inefficient, we can have Lambda at edge functions that will inspect the user agent GTP header and then redirect based on the device type. And so therefore, because our device is a mobile device, then the images is going to be asked into our S3 bucket, and going to be like 640 by 320, which is a lower resolution of our cat picture, and this is the picture that will be returned by our S3 bucket into our mobile device. So the Lambda at edge function was able to modify the request to change the target of these requests. So other way Lambda at edge, we can use Lambda at edge is for like the global application. For example, your client gets the website from the S3 bucket, and then the dynamic API request it sends it into the CloudFront to leverage the cache, but your Lambda function can also be used, for example, to query data into DynamoDB table, which gives you a fully global and serverless way to do an API in AWS. Okay, so this is it for the global application. Next, we will be getting into so now we are getting into what I would call one of the trickiest bit of the CloudFront. It took me forever to understand the actually the subtle differences here, and I am going to try to explain to you. So if you don't get it, don't worry. I'm really trying my best here, but let me just tell you right away. This is tricky and very peculiar. This may help you on one question in the exam if you understand what I'm doing correctly. But if you don't like stress it out really. So the idea is that we want to have CloudFront talk to our our ALB using HTTPS. Using HTTPS to have secure communication between our client, our CloudFront distribution, and our application load balancer. So the client is going to issue a request for example.com, www.example.com, and is going to send a host header value as well, because we have SNI enabled, server name indication enabled. So it's going to so it's saying that host I want to reach is www.example.com. On top of it, in the request, we are going to have headers, and we'll have different values. And this is something we have seen that will be very helpful in case of caching. Okay, so it reaches our CloudFront distribution, and we are going to set it up with HTTPS. That means we have to set up a host name, maybe using Route 53. So www.example.com, we have to give a SSL certificate to CloudFront using ACM, Amazon Certificate Manager, for example, which is going to be an SSL certificate for www.example.com. Otherwise, HTTPS would not work. And then the origin is where it will send this request to is going to be origin.example.com. You are able to see that. So far so good, and this should be very easy. Next, our application load balancer is also HTTPS enabled, okay, and the host name has to be origin.example.com, because you want the CloudFront distribution to be able to access your ALB. Therefore, we have to load an SSL certificate onto our ALB, which is called origin.example.com, and which makes sense here. And so when CloudFront establishes an HTTP connection with our server, things would work. And this and yes, but with a twist here, it would work, but with a twist. So this is host header is here. The host header is extremely important. As you can see on the left hand side, the host header currently is www.example.com, and so if the host header is forwarded onto the ALB, then www.example.com will not match the host name of our ALB, which is origin.example.com, and therefore, even though it may work as a connection, CloudFront will refuse the request. So in this example, the host header makes sense when you talk to CloudFront, but it doesn't make sense to forward that host header to the ALB, because the host name is entirely different here. So what you have to do is indeed to configure CloudFront not to forward the host header. In this case, CloudFront will automatically add a host header value of the origin, which is going to be the correct one, and which is like origin.example.com here. And now the request and the responses will work in this example. So hopefully that makes sense. It's a very tricky example, and it's going to get even trickier in the next slides. So in this example, we see that to make it work, number one, we need to make sure that we are not forwarding the host header from CloudFront to the application load balancer, in which case CloudFront will add the correct host header for us. And on top of it, if we look in the CloudFront distribution, we have one SSL certificate for the www.example.com, And if we look in the ALB side, we have second SSL certificate for origin.example.com. So in this example, we have to manage two SSL certificate, and this is fine, but we have to remember this, that we are managing here two SSL certificates. Now what if we have another configuration? So our client talks to CloudFront, and this time CloudFront has the exact same configuration as before. So everything is good. But if we look at the origin now, the ALB, because we only want to have one SSL certificate, we configure the ALB to ALB, the host name www.example.com, and the SSL certificate to be www.example.com. In this case, well, things are not going to work properly, because the CloudFront will try to redirect to the origin www.example.com, but it turns out that it's itself, so there will be like a loop, and it's an impossible configuration, because the CloudFront distribution will loop over itself. And so the question is, why did I show you this? Okay, well, I am showing you this just to show that this is an impossible configuration. Still, some of you know the exam may trick you into thinking that this is possible. So the idea is that we wanted to only have one SSL certificate, and this configuration particularly doesn't work. You need to manage two SSL certificate, one for the ALB and one on the CloudFront. But let's look at another configuration that may work. So we have our CloudFront distribution on HTTPS, and the host name is www.example.com. The SSL certificate is again www.example.com, which is correct, and the origin, it has to be something different than our CloudFront host name. So we are getting back to origin.example.com. Now our client does the exact same request as before, and so our application load balancer now is going to be configured a little bit differently. So it's going to be configured with HTTPS, and the host name is going to be like origin.example.com, so that our CloudFront distribution can access our ALB, but the SSL certificate we are going to load onto our application load balancer is going to be a different one. It's going to be www.example.com. So you may be asking, where this is now here the weird case, okay? Because if we try to reach the host name, then things are not going to work. And I'm saying yes, in some cases it will, okay, and no, in some cases it won't. So if you forward the host header, so if the host like www.example.com from the client gets forwarded to the application load balancer, and then it will match the SSL certificate on the application load balancer, and that's a tricky bit to see. So in this case, if we do forward the host header, CloudFront will accept this request. And so to make sure the host header gets properly forwarded, or the correct value is added, you could use Lambda Edge function to modify the viewer request to add this host value that is going to be matching the one the ALB needs to be functioning. So if you are not forwarding the host header, then there's going to be a problem, because CloudFront will automatically add the host header, a value of the origin, which is origin.example.com, and the origin.example.com will not match, and the SSL certificate of www.example.com, and the request will fail. So in this example, what have we gained? Well, we have gained that now there's only one SSL certificate to manage, and it's loaded on both the CloudFront origin and the CloudFront distribution, but it has to have a host header to be kept alongside your request to work. So I know this is very tricky example. It took me forever to figure out this and try to explain it to you in a very easy way. If you are not understanding what I just did, don't worry. If you did understand, awesome. Maybe this will help you for one question. But the host header is extremely tricky. It has to do with the HTTPS. CloudFront configuration is extremely tricky. I had to play a lot to make this work. So hopefully I did explain myself clearly. And if you don't, please just revisit this video, revisit this lecture. Just forgive me. Okay, and I hope you liked this lecture nonetheless, and I will see you in the next one.